Okay, the purpose of this evening's video is mainly actually to try the new video camera I'm using at the moment, and this is a Panasonic TZ40 camera. I'm running it in the high definition mode at 50 frames per second. I also expect hopefully it will give you better image quality because it has quite a fast lens. Obviously it's a far better quality than the little Mobius camera I've been using before. That was very convenient but a bit lackluster in audio and sound quality. Also, to sort of get away from the jerky sort of movements from, obviously this is mounted on a baseball cap on my head, obviously that's where you usually wear a baseball cap. It has a proper image stabilizer built in, and I'm hoping that it will get rid of some of the sort of like the jerky movements that people often complain about on my videos. The reason why it's mounted on my head is because it's convenient and it's nice to have both hands available to sort of, when you're working on stuff, it's easy. Really it's more or less ideal because if I'm looking, whatever I'm looking at is usually what I'm talking about, so you know it sort of doesn't mean I don't have to have multiple cameras set up and things like that. So yeah, hopefully it won't be it will be a big improvement. Certainly in sound quality should be much better. The audio and from the Mobius was pretty poor. So just as like a sort of padder video for this evening, I'm just this Patrolman, Realistic Patrolman Pro 2026. I did an alignment on it a couple of days ago, and it all went fairly well. It was a slightly off tune, but there was one thing that really stood out, and it seemed to be that it should be the sensitivity should be about 1 microvolt, and you should be able to hear modulation at 1 microvolt when you feed in at the low band. Now this is the low band at 78 megs. Now, to be honest with you, I'm never going to use this band. I mainly use these for some of the ham bands, but mainly for the aircraft band. I initially thought, well, maybe the Marconi is not putting out the correct signal, but I'm pretty sure it is. Obviously, down to microvolt level, it's very hard to measure the RF level at that sort of voltage, even with a scope or anything actually. You need a special dedicated RF meter. So what I've done is I bought this. This is a ham radio I keep in the house. The scanner I keep in the house, and I've set them both to 78 megs. Now I assume their performance is going to be pretty similar. And this is what I've found is that when I'm injecting, you can hear the 1 kilohertz AM modulation into the whatever this is, Gregcom or whatever it is. It's a copy of some Japanese radio, no doubt. If it's made in China, they're usually copies. It's not a bad little radio actually. They're only cheap. But as you can hear here clearly, you can hear the modulation, and that's with that's 5 microvolts going into it, so it's working absolutely fine. But if you notice, if I plug it into the Realistic, you can hardly hear it. Now, it's only at these lower bands it seems to be a problem. If you move up to the higher bands, change the frequency. Let's go to 120 megs, and that will fit you right in the middle of the air band. So let's try program 120 meg. Okay, I think we're transmitting on an FM signal, so we need to go to AM. So we need to go to AM 55%. Okay, you can hear that clearly. I'll drop the RF level back to, that's about 1.5 microvolts, and you can hear clearly it's still working. And we'll try and program this if I can remember how to do it. Go to airband, I think. But the easiest thing to just search down to 120 megs. It's probably an easy way of doing it if I can remember how to do it. How do we do this? Is it manual? 120, enter. No, 0, enter. No, but have that. Is there a shift key? Trying to remember how to program the scanner. Tune. Here we go, this might be it. So let's turn that off a minute. Program 120, enter. There we go. Now still sounds louder on this radio. That's very good. That's down to half a microvolt. I can hear that. As I can still on here actually. So it seems to me the response of the set's pretty good at the airband frequency, but anything below the airband frequency, the set's not working properly. Now, I think what it is there's an RF chip that is dedicated for that frequency. Let's see if I can show you the circuit diagram. Okay, so find the document, bear with me. Okay, service manual. I don't know, this will be a good test for the camera as well. Now this is the chip I think is the problem, IC3, which is an LA1186N. Now going through there's the LA11, where are we? IC3, where are we? Be an RF amplifier. That's audio amplifier. There it is, LA116N. Now, the reason why I think that is because it's actually got quite a nice little diagnostic of performance problems. Let's go back. Bear in mind this video is mainly for testing the quality of the video camera rather than anything else. For focusing at close distance and sort of handling things like LCD screens and things. This is the alignment procedure I went all the way through. Now, here we go. No, this is the audio problems, RF section. Is the sensitivity problem? Is the sensitivity on all bands abnormal? No, it's not. Is the 800 bands abnormal? No, it's not. Is the UHF band abnormal? No, it's not. Defective VHF band, check IC3 and associated circuits. So I'm going with IC3 as probably being zapped. You know, it might have been, I don't know, struck by lightning. I don't know the history of this radio. It does seem to be that possibly the airband is a little bit insensitive. So what I'm going to do is order another chip, and then I'll carry out another alignment on it. And see if we get any improvement in performance. At the end of the day, I think it only cost me 15 quid. It's not the end of the world, but it's quite a nice little radio, and I would like to mount it in the car. But all the time it's not performing properly. I think I'll probably give it a miss. But thanks for watching, and I hope this video has come out better than the previous.